Hi everyone. Today we're going to be doing is we're starting to work with polynomials. First thing I want you to do is take a second, and we're going to learn what polynomials are and how to add them. But I want you to first take a second. You can pause it here. You're going to be writing down a definition for each of these terms. So variable, coefficient, factors, terms, and polynomials. So write a definition. You can look it up on the internet and put an example of each one, and you can work with your partner beside you, and you should be able to come up with a definition for each. So pause it here, find a definition for each one of those. Some of them are in the book, in the glossary. Variables in the book, terms are in the book, polynomials in the book. I'm not sure about factors. You can try looking for factors in the book. I'm not sure about that one. So definition in words and an example over here. Okay, so pause it now, look it up, and then you can return to the video in a second. So now you should have all of these filled out, all of your definitions and examples of each. I'll be using these words today, so hopefully that'll help you with some of the definitions. I'll zoom in here a little bit. Simplifying expressions. So what an expression is just basically a polynomial. So it'll be a combination of terms for sure, and it'll be a polynomial that we can then simplify. So what we're looking for when we're simplifying expressions is we're looking to collect like terms. Collect like terms. And what a like term is a term or two terms or multiple terms that have the same variable and exponent. So like terms have the same variable and exponent. And I'll give you some examples and non-examples here. Exponent. So examples. Some examples of like terms would be 2x, 5x, negative 16x, 0.5x. All of those, I can't see that last one, all of those have the same variable, so they are like terms. Another example could be 3y squared, 7y squared, negative 3.1y squared. So these are all like each other because they have the same variable, they all have a y, and they all have the same exponent on the variable y squared. The coefficient, which is the number in front, doesn't matter. We're just looking at the variable and the exponent on the variable. Some non-examples. So non-examples. Here's some non-examples. 2x, 3x squared, 9x to the power of 3. Those are not like terms because while they all have an x, the exponents are different. This guy's a 1, that guy's a 2, that guy's a 3. So those are not like terms. Another example of not like terms would be 2x, 3y, 5z, things like that. So the variable is different. So those are not like terms. Okay, so when we're simplifying expressions, we're going to collect like terms. Like terms have the same variable and exponent. So some examples, some non-examples. We'll be going through these when we go through the examples. So number one, simplify the following expression. So you're only ever going to have to simplify these. You will never solve an expression, only simplifying. So if I look at this, I notice that the 2x, its variable is x, and the exponent is 1. So I look for in the rest of the expression, it's called an expression, and I look for something else that has just an x. So the other guy that has just an x is the negative 4x. So I know this says minus 4x, but that minus is really the same thing as a negative. Make the brightness better here. So now I'm going to circle this guy. So those guys are like each other. They're like terms. I can put those guys together. I'm going to collect them. The other ones that are like each other, I didn't bring it up over here in the examples and non-examples, but this doesn't have a variable, and this doesn't have a variable, so they're like each other as well. So positive 3 and negative 5, those are like each other as well. So when I go to write my answer here, my simplified version, oh, I guess this pen's not going to work. When I go to write my simplified version, I'm going to do my x's first for no reason other than I want to. So this is positive, so positive 2x minus 4x. Positive 2x minus 4x would be negative 2x. So on your calculator, you can just go 2 minus 4, where the x's don't really matter. We're just going to write those. They go along with it. Zoom in a little more. And then I do the ones that are in blue, so the ones without variables. So positive 3 minus 5, and write negative 2. So positive 3 minus 5 is negative 2, so I write negative 2. Negative 2 is the same as minus 2, so this is my answer. Negative 2x minus 2. I can't put this together with this because they don't have like terms. So it would be like I was adding apples and bananas. They're not the same. I can't count them as the same, so there's nothing I can do. That's my answer. So let's look at B now. So for B, first thing I'm going to do is look for like terms. So this guy, my first one has an A. The only other thing with an A would be negative 7a. So note how I circle the operation in front of it. So negative 7a or minus 7a, that gets circled. So that's the like term with the negative. Then I look at my second part here. So B and negative 5b and positive 3b, they both have b's. So again, note how I circled the operation in front, or the sign in front of it. And then nothing's like before because it doesn't have any letters, so it's just positive 4. So then, when I go to collect like terms, a minus 7a. The number in front of a is 1, so it would be 1a minus 7a, which would be negative 6a. The b's, I've got negative 5b plus 3b, so that gives me negative 2b. And then there's nothing like the 4, so it's just going to be written 4 plus nothing is just positive 4. So that would be my answer. So again, like the other one, I've got apples, bananas, and let's say oranges. None of those are alike, so I can't put them together. So that's my answer. I have simplified it as much as I can. Okay, so pause where you need to, rewind it where you need to. That's what you should be getting. For the next one, they start getting a little trickier here. So for this one, now I've started getting some exponents in here. So same idea though. So I'm going to be looking for things that are like 2x squared. So I look for things that have an x squared. So that has an x, but it's not x squared, so it's not like it. This guy doesn't even have an x, so he's not like it. This guy is 2x squared, so he is like the other 2x squared, so I'm going to circle that guy. Nothing else has an x squared, so I'm done with those. Then I'm going to look at the x's. So the positive 4x, the 9 doesn't have an x, so it's not like that. It's not like this guy, he's like the x squared. It's like this negative x, just an x by itself, with no exponent, I mean. Great, nothing else has an x, so I'm done with those. The next ones are going to be the 9s, so they don't have any variables. So now when I go to collect like terms, I just do all the x squared terms, so 2x, positive 2x, plus 2x, sorry, positive 2x squared plus 2x squared would be 4x squared. Positive 4x minus x, so there's a 1 in front of this guy. So positive 4x minus 1x, that would give me positive 3x. And then I've got negative 9 plus 9. Negative 9 plus 9 is 0. I can write 0 or not. I'm going to choose not to, but you can if you want. So that is as simple as it gets. These guys are not like each other. We've got apples and bananas. There's nothing we can do. So that's that one. For D, now D I tried to make it a little more complicated, so I put brackets here. But the thing to remember with brackets, and we talked about this with exponents, if I just look at the first bracket here, it's got a 1 as its exponent, and it has a 1 in front. It's not written, but there's a 1 in front here. So if there's a 1 in front, or it's just 1 of all this stuff. So really, it's just 4x plus 5y. So the brackets are not doing anything. Same with this one. So it's a positive 1 in front. It's not written, but there's a 1 in front here. There's no exponent here, so it's a 1. So the brackets aren't doing anything. So it's just going to be 2x minus 5y. Then I go to find like terms. So here's the 4x. The other thing with an x is positive 2x. So I'll circle the positive with it, or the plus. And then I do the y's. So 5y and negative 5y. so they're like each other. So this is going to give me, so this is going to give me 4x plus 2x, so that gives me 6x. 6x. 5y minus 5y, so positive 5 minus 5, I have 0 y's left, plus 0y. I don't have to write the 0y because 0 times y is 0, and 6x plus 0 is just 6x, so my answer here is just 6x. Okay, so pause it if you need to, rewind it. Let's go to the next one, it gets a little trickier. So for E, so you should take a second to write this down if you're not writing down the question, you should be. My first one I'm looking at is the x to the power 3. I've got 2.1 x to the power 3. Now I'm looking for things that have x to the power 3. So that has an x, but it's not to the power 3, so it's not like that guy. 3.5 x to the power 3, that's like the other x to the power 3. Negative 2.4 x to the power 3, that's like that guy. It's like the other one. Then I'm going to do the 4.x. So this guy just has an x. The number doesn't matter, the coefficient doesn't matter. So just an x. This guy has an x squared, so he's not like the x. And this guy has an x squared, so he's not like the x. So that's the only one that's like that guy. That leaves me with the x squareds, and they are like each other. So then my answer here would be 2.1 x to the power 3 minus 3.5 x to the power 3 minus 2.4 x to the power 3. So just adding all those up on my calculator, I would get negative 5.9, 3.8 I believe, negative 3.8, negative 3.8 x to the power 3. The x doesn't have anything else like it, so it's just going to be 4.8x. And now I've got to put the x squareds together. So positive 0.1x squared plus 8.6x squared would give me positive 8.7x squared. And that's all I can do. So I'm done from that point. That is simplified as far as it goes. For this one, so you can read the question. So you should take a second and write that down if you didn't have it printed off. Avery and Logan both have jobs cutting grass. They both work the same number of hours, but their pay structures are different. Avery gets paid $12 per hour and pays a flat fee of $45 for the lawnmower rental. Logan gets paid $15, but pays $60 for the lawnmower rental. So what's important here? So she gets paid $12 per hour, and she pays a flat fee of $45. Logan gets paid $15 per hour, and he pays $60 for the lawnmower rental. So we need to write an algebraic expression for each of Avery's and Logan's pays. So the first thing I'm going to do is I need to introduce a variable. So I don't know how many hours they're going to work, but I know that I have to multiply, in Avery's case, I have to multiply the number of hours by 12, and in Logan's case, I have to multiply the number of hours by 15. So what I'm going to say is, I'm going to say let x equal number of hours worked. So I'm going to use x as my variable because I don't know how many hours they're going to work. It varies. So then for Avery, she's going to get paid $12 for every hour she works. So she's going to be $12 times the number of hours, or $12 times x hours. So it's going to be 12x. And then she pays a flat fee of $45. So that's going to be subtracted out of her pay because she's paying that. So minus 45. So that's an expression for Avery. For Logan, you can probably guess this one now. He's getting paid $15, so it's going to be 15x. So $15 times the number of hours he works is x. And he pays $60 for the rental, so minus 60. So those are our two expressions for Avery and Logan. For part B, it says determine a simplified expression for their combined pay. So when you combine things, it means you're going to add them. So if you're combining 2 and 3, for example, if you combine 2 and 3, you get 5. What did you do? you added them. So we're going to add these guys up. So I'm going to have 12x minus 45 plus 15x minus 60. So those are combined, and this is equal to the pay. So the pay is equal to 12x minus 45 plus 15x minus 60. And then in order to simplify this guy, I need to collect like terms. So the 12x is like the 15x. So those guys are going to go together because they both have an x. The negative 45 doesn't have a variable, and the negative 60 doesn't have a variable, so they're going to go together. So all together, when I work that out, I'm going to have 12x plus 15x. 12x plus 15 is 27x. So I'm going to have 27x. Negative 45 minus 60 would be negative 105. That's as simple as I can go. I can't put the x's together with the things that don't have an x, the terms that don't have an x. So that's as far as I can go. That is simplified. For part C, it says use your expression to determine how much they'll get paid if they both work 18 hours. So what I'm going to do is I'm going to replace the x with 18. So I'm going to say let x equals 18. Oops, we can't see that. Let x equal 18. So then the pay is going to be equal to 27 times 18 minus 105. Oops, I need a bracket there. So this should be equal to, I worked that out on my calculator, 27 times 18 minus 105, and that gives me $381. So therefore, their combined pay, their combined pay is $381. And I'm done. So what you should be able to do now, take the rest of the class, and again, you should be pausing this, rewinding it, listening to whatever part you need to listen to. Make sure you get this down as your note. You should be writing the questions down too. Independent practice questions are page 109, number 5, number 9, number 12 AB, 16, 17, 18, and 20. Okay, so rewatch this if you need to. Good luck.